Like a chip in a powerful computer, our brain is the human body's control center, constantly sending electrical signals to every part of our body. This is responsible for every movement, thought, and sensation that we experience as these signals travel through our nervous system. As you navigate your day by performing tasks such as watching this video, grabbing a cup of coffee, or even typing a message, it is actually your brain telling your body what to do. For some people, like those with paralysis from a spinal cord injury, the brain signals get interrupted. Normally, we have cells called neurons that carry neurotransmitters from one cell to the other until it reaches our target region of the body. However, the damage of these cells prevents the appropriate signals from reaching body regions from the brain, and even vice versa. Think of it like a broken highway. No matter what vehicles pass, they cannot pass through a major break in the road. This interruption makes it impossible for the brain to tell muscles what to do, trapping people in a body that they can't fully control. Although it may be easy for us to grab something for our desks, for instance, those with paralysis have the same needs but cannot fulfill the action. So, how are these problems really addressed? Well, that's where brain computer interfaces, or BCIs, come in. BCIs aim to bypass damaged neural pathways, that is, bridges between neurons, and create new connections between the brain and external devices. They allow the brain signals to be sent directly to devices like computers, robotic arms, or prosthetics. Since the brain contains instructions for what we desire to do, it essentially allows the result to be maintained by an artificial pathway. While BCIs involve a lot of complex technology and science, it is important to know that they function under three key steps. These are recording, translating, and executing. So let's break these down. In the recording phase, electrodes are used to pick up electrical signals from the brain. Neurons fire when you think about moving, and the electrodes capture these signals. You can think of this as a machine that wants to listen to your thoughts. The combination of multiple neurons firing yields different readings for each action. After the recording phase follows the translation phase. These raw signals are sent to a computer, which interprets the brain's intention. It might decode a signal, like wanting to move your hand, so that the machine understands what you wish to do. After receiving and interpreting the signals, the executing phase starts. The system sends a command to an external device, such as a robotic arm or a computer mouse, allowing it to perform the action just as your body would. Although this technology is still in a phase of development, BCIs have already shown promising applications in several areas. They can allow people with severe paralysis to use computers, control wheelchairs, or even move prosthetic limbs just by thinking about the action. As BCIs continue to develop, prosthetics could become so advanced that they mimic the movements of a real human hand, making everyday tasks easier for those who rely on them. This kind of control is a huge leap forward for individuals living with paralysis or limb loss, giving them more autonomy over their daily lives. Now, let's look into a current application of a BCI to explore these possibilities further. One of the most exciting developments in the BCI field comes from a company called Neuralink. Their goal is to create a brain implant with tiny electrodes that are thinner than human hair in order to read brain signals with incredible precision. In preclinical trials, Neuralink tested this technology on animals, demonstrating its ability to record brain activity and control devices. Now, the company has started its first human trials. In one case, a participant with the Neuralink implant was able to play chess by controlling the computer mouse using only his thoughts. Nolan Arbaugh was unfortunately paralyzed from the shoulder down from a previous car accident. He claimed that the surgery was super simple and even played a video game called Civilization 6 for 8 hours straight. Nolan isn't the only one benefiting from this implant. Alex, another participant, recently got the chip from Neuralink and has also shown promising results. He is now able to spend time designing 3D models. Additionally, he also plays first person shooter games with Neuralink, such as Counter Strike. Although promising, test subjects have claimed some small issues with the technology, such as glitches and latency issues. However, as more trials occur, Elon Musk, the CEO, claims that his BCI will eventually be able to effectively target a wide range of neuromuscular conditions. Now, it is important to consider some of the challenges and ethics involved in this technology, especially given its implications and reach to a variety of patients. Although the potential is exciting, there remain many challenges to overcome. Brain surgery is invasive, and there are risks of infection or device malfunctions. Researchers also don't fully understand the long term effects of implants in the brain, which can pose a risk for long term use without substantial research. And then there's the issue of ethics. Who should control the data from the brain signals? How can we ensure that the technology isn't misused? And how can we also ensure that it is distributed equitably? Looking back at the subject of Neuralink, an ethics group called Physicians Committee for Responsible Medicine recently asked the FDA to disqualify results from Elon Musk's experimentation, slamming the entire research. Over 20 formal employees have complained about the rushing of these trials, putting great pressure on the staff to accelerate the result. In turn, this supposedly led to the unnecessary death of many animals. Like most medical interventions, there is no simple answer to many of these questions. However, before BCIs become available to all patients, it is generally recommended that such aspects have been heavily considered to ensure the meeting of ethical standards. In summary, BCIs represent a fascinating blend of neuroscience and technology. They give us a glimpse of a future where the brain can control external devices, restoring independence for people with disabilities. While companies like Neuralink are making incredible progress, it will take time and careful research to overcome the challenges involved. But if successful, BCIs could change the lives of millions, turning what once seemed impossible into a reality.